All right, let's jump right in. Today, we're going to get hands-on with Postman and really master two things that can be a huge pain point in API testing: how to handle file uploads and how to navigate the whole world of authentication. You've been there, right? You're looking at a web page with a Choose File button, but your job is to test the API on the back end. How in the world do you actually send a file through a tool like Postman? It feels like it's just meant for text, but trust me, it's not. So, here's how we're going to break this down. First, we'll solve what I call the payload problem. That's all about file uploads. Then we'll tackle the access problem, which is your guide to API keys and tokens. And finally, we'll demystify the delegation problem with a look at OAuth 2.0. Okay, let's dive into challenge number one. When you send any kind of data to an API, that data is called the payload. But here's the thing. A file isn't just a simple bit of text. It's a whole different kind of data, and you have to package it in a very specific way for the server to understand it. And the solution to that packaging problem is called form data. The best way to think about it is like a digital envelope that has different compartments. You can put some text, like a username, in one compartment, and then you can stick a whole file, like a profile picture, in another. It lets you send both in a single, neat package. It's absolutely the standard for this stuff.
Now in Postman, this is way easier than it sounds. It's really just 3 simple steps. First, you've got to set your request method to post because you're sending new data to the server. Then, head over to the body tab and just select form data. And finally, this is the magic part, you enter a name for your key, but instead of leaving it as text, you click the drop-down and change it to file. As soon as you do that, Postman will let you pick a file right off your computer. Simple as that.
Now pay attention, because this next bit is a tiny detail that causes so much frustration. Your API's documentation is going to tell you exactly what key name to use. And a lot of the time, it's a super subtle difference, like using the word file for one upload, but files with an S for multiple. Getting this one word right can be the difference between everything working perfectly and you pulling your hair out over an error message. All right, we've figured out how to send the file. But now we have to deal with the API's digital bouncer. You can't just walk up and start making requests. Most APIs in the real world are going to stop you at the door and ask, "Who are you, and are you on the list?" And that whole process is called authentication. It's not just about proving who you are, it's also about what you're allowed to do. It's the system that makes sure you can see your own data, but not someone else's. It's totally fundamental for API security.
The simplest forms you'll see are basic and digest auth. And the big difference here is security. With basic auth, your username and password are just sent in plain text. Super easy to set up, but not very secure. Digest auth adds a simple layer of protection by scrambling or hashing your credentials before they're sent, which makes it a bit safer if someone's snooping.
I love this analogy because it just makes the two most common modern methods click instantly. An API key is your permanent secret key. You get one, you hold on to it, and you use it for a long time. A bearer token, on the other hand, is temporary. It's like a concert ticket. Whoever holds it or bears it gets in. So how do you actually use them? An API key is usually a key value pair that you pop into the request headers. A bearer token is even easier. It's just one long string of text that you also put in a header, specifically the authorization header. The beauty of a bearer token is that it's self-contained. The server sees it and knows you're good to go without having to check anything else.
And that brings us to our final act, the real heavyweight champion of modern API security. It solves a really common but tricky problem. How do you let one app use your data from another app without just giving it your password? The answer is OAuth 2.0.
This right here is the magic of OAuth 2.0. You see it every day. You go to a new website and it asks, "Hey, want to log in with your Google account?" When you click yes, you are not giving that website your Google password. No way. Instead, you're just telling Google, "Hey, it's cool. Give this other app a special limited access ticket to verify I am who I say I am." That's secure delegation. This secure handshake happens in 4 key steps. First, the app you're using says, "Hi, I'd like some access," and shows its ID card, the client ID. Second, the service, like Google, turns to you and asks, "Yo, is this okay?" And you click approve. Now, this third step is absolutely crucial for security. The app gets a temporary one-time use code. It then, secretly, on the back end, trades that code in for the real, powerful access token. This means the token is never exposed in your browser. And finally, the app uses that token to do its thing on your behalf. Okay, so let's boil all that down. What are the big takeaways? Number 1. For file uploads, form data is your friend. And for the love of all that is holy, double-check if the key is file or files. Number 2. Authentication isn't one size fits all. It can be as simple as basic auth or as robust as bearer tokens. And number 3. OAuth 2.0 is the gold standard for letting different apps talk to each other securely without you ever having to share your password.
And that leaves us with a pretty big question to chew on. Think about it. We connect everything nowadays. Our phones, our cars, our social media, our smart fridges. The old username and password system just can't keep up. So, what's next? How will we secure our digital selves as we connect more and more pieces of our lives?